Hi all, welcome to i-tutor Academy. In today's session, we will start with Unit 5 of Mmpc 009, that is Planning and Control for Mass Production. So, what are the objectives of this chapter? After completion of this unit, you should be able to understand the nature of mass flow production, identify the situations under which mass production is justified, and appreciate both the desirable and undesirable features of mass production, and see how assembly lines and fabrication lines are designed. Get an idea of how modular production and group technology could be used to advantage in mass production, and understand the role of automation including robotic in mass production. Okay, so these are the objectives. So this is block 2, and in last video we covered till block 1, and in block 2, that is operation, planning and control. So here we start with unit 5, planning and control for mass production, and unit 6, 7 and 8 under this block 2. Unit 6 is planning and control for batch production, and unit 7 is planning and control for job shop production, and unit 8 is planning and control of projects. So these are the four chapters under this block 2. Okay, so what are the structures of this unit 5? Let's see. So there is an introduction part, when to go for mass production, features of mass production system, nation of assembly lines and fabrication lines, design of an assembly lines, line balancing method, problems and prospect of mass production, modular production and group technology, automation and robotics, summary, keyword, self assessment, exercise, and further reading section also here. So let's begin with the introduction part. Kinds of production system, that is flow shop, job shop, and projects. Okay, as you already know, production involves the transformation of inputs such as men, machines, material, money, information, and energy to desirable output in the form of goods and services. So it is customary to divide production system into three categories: the flow shop, the job shop, the project. And the flow shop exists when the same set of operation is performed in sequence repetitively. The job shop exists where the facilities are capable of producing many different jobs in small batches. The project is a major undertaking that is usually done only once, and it consists of many steps that must be sequenced and coordinated. And the flow shop employs specially purpose equipment designed specially for the mass scale production of a particular item, or to provide a special service. And the job shop contains general purpose equipment, that is, each unit is capable of doing a variety of jobs. And the project, like the flow shop, requires a sequence of operations, except that is the sequence lack repetition. Each project operation is unique and seldom repeated. For example, the production line for automobiles is a flow shop, and the machine shop that makes hundreds of different gears in batches of 50 at a time, or is a job shop. Building a bridge or launching a satellite in space is a project. So this unit is concerned with the problem of mass production encounters in flow shops, and batch production and its problem, job shop and projects are discussed in further unit of this block. And nature of mass production. What is the nature of mass production? It was a Henry Ward who in 1913 introduced the assembly line and the nation of mass production. So it is enormous to think that the mass production means production in millions or for the masses, and through this may be an outcome. And mass production refers to the manner in which a product is produced. This involves the decomposition of the total task into its minutest element, show usually on a proceedings. So this is a precedence diagram, and uh, the subsequent regrouping of these elements according to the norms of production. An assembly line consists of workstations in sequences where at each workstation the above carefully designed portion of work is done, and mass production requires that all like part of an assembly line be interchangeable, and that all parties would be replaceable and characteristics which permit production and maintenance of large quantities. The assembly line is a production line where material moves continuously at a uniform average rate through a sequence of workstation where assembly work is performed. Typical example of these assembly lines are car assembly, electrical appliance, TV set, computer assemblies, and toy manufacturing and assembly. Diagrammatic sketch of a typical assembly line is shown in figure 1, and the arrangement of work along the assembly line will vary according to the size of the product being assembled and the president's requirement, the available space, the work element, and the nature of the work to be performed on the job. And so here is the diagram for workstation in material movement between workstation could be manual, as for instance when operators sitting in a row pick up the part for from the output of the previous operator, so work on it and leave it in a bin to be picked up by the next operator, or through the use of conveyors which carry the part at a predetermined speed, so chat there is a adequate time for each workstation is complete its allocated share of work. And there are various type of conveyors that are used in assembly line. The most widely used are belt, chain, overhead, pneumatic, and screw conveyors. And it may be of interest to note that assembly line could have varying degree of automation, starting from the purely manual on the one hand to the fully automated line on the other hand. So however, the underlying principle of the assembly line and mass production remain unchanged, although the labor content may be reduced through robotization. Okay, so next is when to go for mass production. So mass production, what time mass production will start? So it is generally agreed that mass production is justified only when production quantities are large and product variety small. The ideal situation for mass production would be when large volume of one product, that is without any changes in design, are to be produced continuously for an extended period of time, and thus the rate of consumption or demand of the product as compared to the rate of production decides whether continuous or batch production is called for. Obviously only if the rate of demand is greater than or equal to the production rate, mass or continuous production could be sustained. If the rate of demand is less than the production rate, batch production with suitable inventory buildups could be resorted do. And apart from the above consideration, the economics of the matter would have be evaluated before deciding as to whether an assembly line is justified or not. So this is an example. 5.1 is here, and solution also here. You just go through it, and based on the example, here is a figure 2, cost of 3 alternatives is here. Okay, so there is purchase, produce at the individual station, and produce on assembly line. Okay, so please refer this example so you will get more idea. Next one is features of mass production system. What are the features? A mass production system operating as a continuous floor line exhibits certain desirable and undesirable features. So these are summarized below. Advantages. What are the advantages? The first one is a smooth flow of material from one workstation to the next in a logical order. Although the straight line flow in common, other pattern of flow exhibit in figure 3 are also employed when constraints on space or movement so indicate. So this is the kind of flow patterns. Okay, combination of U and the line flow pattern, combination of line flow and the S type pattern, and combination of flow and circular type. We have already exhibit the following common flow pattern in unit 4 of block 1. So here is I flow, L flow, U flow, S flow, and O flow. So these are this, and Second is since the work from one process is fed directly into the next. Small in process inventories result and total production time per unit is short. Since the workstation are located so as to minimize distance between consecutive operation, material handling is reduced. And little skill is usually required by operators at the production line. Hence, training is simple, short, and inexpensive. Simple production planning and control system are possible, and less space is occupied by work in transit and for temporary short storage. Next is disadvantages. What are the disadvantages of this? And a breakdown of one machine may lead to complete stoppage of the line that follows the machine. Hence, the maintenance and repair is a challenging job. And since the product dictate the layout, changes in product design may require major changes in the layout, and this is often expressed by saying that assembly line are inflexible. Next is the pace of production is determined by the slowest or bottleneck machine. Line balancing proves to be a major problem with the mass manufacture or assembly lines. Supervision is general rather than specialized, as the supervisor of a line is looking after diverse machine on a line. Generally, high investment are required owing to the specialized nature of the machines and their possible duplication on the line. And next is notion of assembly line and fabrication lines. It is useful to consider two type of line balancing problems. That is assembly line balancing and fabrication line balancing. The distinction refers to the type of operation taking place on the line to be balanced. The term assembly line indicates a production line made up of purely assembly operators. The assembly operation under consideration involves the arrival of individual component parts at the workplace and the departure of these parts fastened together in the form of an assembly or sub-assembly. And the term fabrication line, on the other hand, implies a production line made up of operation that form or change the physical or sometimes chemical characteristics of the product involves. Machining or heat treatment would fall into operations of this type. Although there are similarities between the problem of assembly line balancing and that of fabrication line balancing, the problem of balancing a fabrication line or machine line is somewhat more difficult than the assembly line balancing problem. It is not so easy to divide operations into relatively small elements for regrouping. The precedence restrictions are usually tighter in the fabrication line. An assembly operator may easily shift from one assembly job to another, but a machine tool may not be utilized for a variety of jobs without expensive changes in setup and tools. And some methods by which the balance of fabrication operation time can be achieved are as follows: that is, changing machine speed, using slower machine or overtime, and providing a buffer of semi finished parts at appropriate places, and using mechanical device for diverting parts and methods improvement. And next is design of an assembly. The broad objective in design, as you have just seen, the two most important manufacturing development which led to progressive assembly are the concept of interchangeable part and the concept of the division of labor, and these permit the progressive assembly of the product as it is transported past relatively fixed assembly station by a material handling device such as conveyor. The work element which have been established through the division of labor principle are assigned to the workstation so that all stations have nearly an equal amount of work to do, and each worker at his or her station is assigned certain of the work elements. The worker performs them repeatedly on each production unit as it passes the station. And the assembly line balancing problem is generally one of minimizing the total amount idle time or equivalently minimizing the number of operators to do a given amount of work at a given assembly line speed. So this is also known as minimizing the balance delay. Balance delay is defined as the amount of idle time for the entire assembly line as a fraction of the total working time resulting from unequal task time and assigned to the various stations. And Kilbridge and Wester, after studying the variation in ideal time at the stations caused by different assembly line balancing concluded that high balance delay for an assembly line system for a specific product is caused by wide range of work element times and a large amount of inflexible line mechanization and indiscriminate choice of cycle time. However, as we shall see, the cycle time is often dictated by a specific desired production rate, which may not lead to a low balance delay. And division of work into parts, the precedence diagram, the total job to be done or the assembly is divided into work element. A diagram that describes the ordering in which work element should be performed is called a precedence diagram. Okay, so figure is here. So here is precedence diagram for assembly with the 12 elements. Okay, so example is here. So please refer this. And there is no restriction on whether the task 2 is done first or task 4. And these two tasks are unrelated, meaning thereby that they may be done in parallel or even with a partial overlap. Okay, that is about. And next is grouping of tasks for workstation and efficiently criteria. Depending on the desired production rate of the line, the cycle time, that is CT, or the time between the completion of two successive assemblies can be determined. This determines the conveyor speed in the assembly line or the time allocated to each operator to complete his share of work in a manual line. The individual work element or task are then grouped into workstation, such as the station time, that is ST, which is the sum of the time of work element performed at that station and should not exceed that cycle time, that is CT. The precedence restrictions implied by the precedence diagram are not violated. And there are many possible ways to group these tasks keeping the above restrictions in mind. And we often use criteria like line efficiency, balance delay, and smoothness index to measure how good or bad a particular grouping is. These criteria are explained below, that is line efficiency LE. So this is the ratio of total station time to product of the cycle time and the number of workstations. So here is the equation for that. Please refer all these from your Ignou study material, so it will help you more. And there is no satisfactory methodology which guarantee an optimal solution for all assembly line balancing problems. So the emphasis has been on the use of heuristic procedure that can obtain a fairly good balance for the problem. Okay, so for review of procedures available for assembly line balancing refers to Buffer and Kilbridge and Wester to commonly used method for obtaining a good balance for an assembly line balancing problem are presented in the next session. So this is about today's section. Next subsection we will discuss on next video. So in between any doubt you can contact us anytime, and for more MBA videos you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents Ignou Mba complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 217 885.